Hello, friends. Welcome to Practical AI Ethics, Round 2. I am psyched to be back. Welcome, welcome. Hi, Fancy Appleby. It's going to be a good time. Happy Tuesday. Is it Tuesday for everyone? Is there anyone for whom it is not Tuesday? I guess it's got to be not Tuesday for someone, right? Let me know in the chat if it's not Tuesday for you. Let's see. Is it Tuesday for everyone right now? Like, I know the answer is no. Okay, cool. We have it's Wednesday for folks in Alexandria, in Baghdad, in Beirut, in Bangalore. Okay, so there are lots of folks for whom. Oh wait, yeah, it's Wednesday for lots of people. Well, let me know in Algeria it's Wednesday. There we go. Indigo Wizard, welcome, good to see you. So we will stall for 4 minutes while folks trickle in, and then we'll get going. Hey, Adam stuck around. Adam, you should go to bed. I know how late it is for you. Actually, I suppose that's probably, if it's Wednesday for you, you should be in bed, I guess, is my stance. But even if it is, well, actually, that's not true. It could be the next morning. If it's as late as it is for you as it is for Adam, you should go to bed. But Manohar, welcome. Good to see everyone. Adam will go to bed when I finish what I'm trying to do with assignment. All right. Well, we are going to have a good time today in Practical AI Ethics. So to recap, I guess if this is your first time, hi, my name is Will. I will maybe give myself, I don't know, by day 3, I think I'm not reintroducing myself, because if you haven't watched parts 1 and 2, like, you probably aren't, this probably isn't going to make sense for you. But day 2, you actually could jump in today. So I will reintroduce myself when things get going. But last time we talked a lot about philosophy. We kind of turned on philosophy nerd hour. We also explored a data set. We did a lot of exploratory data analysis of this loan application approval data set. And we also actually build our first little model, right? It's kind of a little baby sort of threshold classifier model, where we just tried to find at what cutoff point in credit scores should we give folks loans, right? And that was very, very simplified. And so we're going to kind of make it a little more complicated, use some additional tools, and actually start talking about fairness in our data today, which is going to be great. Fancy Appleby says, if I miss half of tomorrow's meeting because of time, can I still do the feedback form respect? Yeah, absolutely. No worries. Yeah, in fact, I actually haven't pulled, I don't time bound. It's not like, oh, you have to fill it out like immediately, because folks will, watch it a little bit later. If you 2 days from now, like, go and spam all of them, like, I just won't have pulled your name, but if you are like a day later or something doing it, you'll probably be fine. And if it's you, I'll look for your email. Polar Void, welcome. Good to see you. You're tuning in from a different platform. What's this? Are we doing YouTube? Are we doing Twitch? Okay, so we're 7:02. We can get into it. Oh, and actually, I wanted to start today with a Kahoot. We're not going to have audio. Don't worry. It's going to be okay. But we are going to do a Kahoot on fairness. All of the answers are the same for every single one. Polar Void, as I understand, Polar Void was here tuning in from YouTube. So you might actually not have seen his comments, maybe. I don't know. Will the Kahoot have swag? Ooh, good question. I haven't decided yet. I think probably not, but I reserve the right to drop some swag on someone if they win. Okay, let me reorganize all my links, and we will get into it. Oh, okay. So everybody, thank you to everybody who submitted the prompts for the for our ChatGPT silly task thing. So if you have not done these before, I usually have some silly tasks that I let people vote on. So like I've let people pick what I will tattoo on my arm or what color I will dye my hair or whatever. And this time I thought, oh, we'll introduce a layer of ChatGPT. So you give me a prompt, I'll feed that prompt to ChatGPT, and whatever that says, that'll actually be the thing that I'll do. And so today we're all going to vote on, out of all of the things that ChatGPT said, which one will I do on stream? And they're all pretty dumb. They're all pretty silly. Let's see. What is Will drinking? Fancy Alp, we just had some Coke, some Diet Coke. I am now drinking just water. I had some Diet Coke earlier today, but just water today. I was up to 2.5 cups of coffee today, and so needed to back off a little bit. Let's see. Adam asked, "Are the fish still alive? From what will I name my fish?" Yes, we do. Hey, Google, turn on the aquarium light. This might work.
Sorry, I didn't understand.
Dude, ever since I have added my boyfriend Richard to my Google Home, it is actually like not a great experience. It is constantly not understanding me, which is kind of a bummer. But we will turn on the aquarium light semi-manually. Let's see, where are you? Aquarium light. Come on. There we go. You probably won't actually be able to see the fish. I really need to put more water in there, and I will confess that the snail has died, which is really, really sad. Yeah, Richard breaks things, but I love him, and so I will let him break all of the technology in my life. That's what being in love is, I think, maybe. I don't know. I've never checked. Okay, it's 7:04. Let's get into it. So, hello, my name is Will. I'm a software engineer at Google. I'm an AI fairness tester at Google. I'm also a coach at Major League Hacking. I'm also not that caffeinated. I'm also getting my pilot's license. That's a new fun thing. And the biggest thing is that I am a fanatic about trying to make AI not evil. I think that's like a pretty good thing for us to spend time on, right? I think potentially, at least for me, the best. I have a weird dream about AI ethics that I will share on the last day if you remind me, which I think is in a weird way related to why I am personally passionate about AI ethics. But so we'll do a quick recap and we'll dive into what we're doing today, which is making our model better and actually trying to evaluate, is our model being fair? Polar Void says, it almost looks like Bloom, LOL. Are you just talking about the fish back there? It is very bright. Pilot's license, then you can fly to the Isle of Man. Yes, maybe, I don't know. We'll see, Adam. We'll see if I make it out to the Isle of Man. Okay. Oh, Kahoot. Let me pull up Kahoot. That's what we're going to do first. So the Kahoot, we're just going to ask the question, is something fair? Boom. And I did, okay, so I do think I fixed it so that, oh, that's not, let's do classic mode. Oh no, it still says 10 players. I thought I had changed it so that I was an educator now and it would let more people join. So it might limit us to 10 players, we'll see. But jump into the Kahoot. And if you get locked out, I am sorry. I will try again to fix that next time because that's kind of a bummer. Okay, we've got Fancy Apple, we've got Day, we've got Ember and Ashes, we've got Jalapeno. Oh, you have to make a new account. Oh, that's sad. Well, thank you for the tip. I will try to do that next time. So give me some more light. All right, if we're gonna be limited to 10, I'll wait until like 10 folks actually join. Unless we don't get more than 10 folks. Okay, we're at 10. If you are not, so this is Kahoot. I think it's what? Play Kahoot. Oh, go to www.kahoot.it. Oh, we got 11. We got 11 people. I don't know if that means that anybody can join. Oh, I didn't mean to do that. Okay, cool. It looks like we're unbounded. So we're going to start. Every one of these is going to be an ethical scenario, and you are going to tell me if it is fair or unfair. And this is really just based on like Like don't think about it too hard. Just decide, do I think this is fair, right? I do have a right answer for all of these, and we'll talk about why. But I want to see if we have some kind of consensus. Fancy Appleby just discovered that TensorFlow is owned by Google. Well, where have you been, Fancy? What's going on? Okay, so a teacher gives Alice an A and Bob a B, even though they both performed the same. Is this unfair, fair, it depends, or it's not unfair, it's just dumb? I really got to get my... No, that's not what I want. Here, let me... I don't know if there's anywhere safe for me to put my face right now. Maybe I'll just make it small. Okay, so I said this is unfair. It looks like most people agree. Great. We can unpack these things in a second. But where does our board stand? Okay, Embers and Ashes and Alvin and Day and Dr. Racket. We got lots of folks up there. Lots of fast responses. Okay, scenario 2. A teacher gives Alice an A and Bob a B. Alice answered all the questions correctly, and Bob got several of them wrong. Is this unfair, fair, it depends, or it's not fair, it's just dumb? I thought green was discriminatory. Yes. Okay, we can talk about, I may have mentioned this yesterday, we can talk about how hard it is to get a pilot's license when you're colorblind, which I am, and it's just an absolute hassle. Okay, cool. Most people said this was fair, and that is what I said was the correct answer. We can unpack this in a second as well. We'll continue. Okay. Okay, we got lots of folks that have gotten all of them right so far. That makes sense. I will drop the check-in link again. I guess it's the first time I'm dropping it, but... Oh, thank you, Fancy. The doctor gives pain medication only to her patients that are cute. It's unfair, fair, it depends, or it's not fair, it's just dumb. Okay, cool. It looks like basically everybody agrees this is unfair. We don't think that it would be fair for a patient to only give pain medications to our patients that are cute. Also, who gets to define who's cute? This is relevant. Okay. So moving around, jalapeno. Okay, a doctor gives pain medication only to her patients that are in pain. Is this fair or is this unfair? To be fair, I'm not trying to make any of these like tricks, right? Like these are all these are here to kind of prove a point, but they're not trick questions. Okay, we consistently have like 3 people that are not saying the thing that I said, and I would love to like drop in the comments like what your reasoning is, because I want to walk through this and back it. But okay, cool, yeah, we got 11 votes for fair. I would say this is fair to give pain medication only to the patients that are in pain. A doctor gives pain medication to all her patients, regardless of whether they're in pain. Is this unfair, fair, it depends, it's not unfair, it's just dumb? Most of these feel like there could be some nuance. Yeah, I definitely agree there could be some nuance. Pain can be subjective, who decides? Yeah, I mean, I think in general, we do say that, like, as I understand it, that if you say you are in pain, that generically we just believe that, right? Now, maybe you're not getting like opioids because you say, oh, I have a boo-boo, but like, oh, you say you're in pain, I give you some ibuprofen. Like, it seems like at least as things happen, like generically not that uncommon. Although totally a thing you could dive into, and like describing that subjective experience could be tricky. A doctor goes, okay, yes. So it looks like a lot of people did agree it's not unfair, it's just dumb, and we'll dive into why we had this similar intuition, but that is certainly what I said. But a little bit less agreement here. Some people said unfair, some people said fair, some people said it depends. We'll talk about it. Okay, so moving around. Oh, I should get rid of this little pop-up. Okay, somebody moved up 3 places. A father gives both of his children size 10 shoes, even though neither of them have size 10 feet. Is this unfair, fair, it depends, or it's not unfair, it's just dumb? My screen has so much latency. Yeah, I don't know if that is, I don't know if you're talking about like, oh, like my frame rate is low, or if it's just that my connection is slow, but I don't know. A father, okay, yeah. So I think a lot of us agree this is not unfair, it's just dumb. That sounds about right. One has size 9 feet and one has size 10 feet. It averages out. It's funny that you should say that, because I think the next question does. Oh, okay. I said their size. Okay, yeah. So same scenario. Father gives one child size 11 shoes and the other one size 7 shoes. Their feet sizes are 11 and 7 respectively. Is this unfair? Is this fair? It depends. It's not unfair. It's just dumb. Ooh, okay, on the topic of speed, so this actually isn't really a speed thing. It's more of a redundancy and availability thing. Ooh, okay, this is kind of fun. We have some people saying it's unfair and some people saying it's fair. Okay. Some folks press the wrong button, it seems, but that's something we can dive into. And I think we only have, what, 1 or 2 more? Dr. Racket and Day cleaning up. Okay, 2 more. Father gives both of his children size 11 shoes, even though only one of them has feet that are size 11. Ooh, okay. Should I add me dancing to Kahoot music as one of the dumb challenges you can vote on? If people want me to, I'll add that to the list. Not a whole hour. A whole hour would be excessive, but okay, cool. Seems like a lot of folks agree this is unfair. That is what I had down. But again, if you're disagreeing, like drop what you think. I mean, like Alvin added the detail about like, hey, there's certainly some subjectivity to a lot of this. Ooh, okay. Day has a, or not? Yeah, that is Day has a streak of 8. Will is making us play his Kahoot because it's what we deserve. Smiling face with horns emoji. He'll grow into them. That's true. That could be fair. That could be, well, not fair, but that could be, I don't know. That's like buying a kid like a bond where it's like, yes, like in 10 years you'll get $50. But it's like, yes, in 10 years you'll get a pair of shoes you can wear. Okay, yes, 8 of you were correct. This is fair. This is a tangent, but I've decided that my 2023 linguistic goal, I have a linguistic goal every year. Last year, my goal was to refer to more categories of things as genders. And this year, my goal is to tell anybody who uses the word deserve that it's a bad word and they should stop using it. But that's not a conversation we're going to have now. That's a conversation for another time. Okay, awesome. So what did we see? I think the first thing to call out is that we did actually have quite a bit of consensus, right? There were a few, I think, especially at the beginning, where people were like, I don't know, is there a point? Am I supposed to like game this? Is the answer it always depends? But kind of once we got into it, I think most people had a sense of, at least as we're defining the word fair, like, oh yes, this is fair and this is not fair. And a couple things that were not true. It's not true that we always have to treat people the exact same, right? It's also not true, or it's also not true that it's necessarily fair if we treat people the same, right? So treating people the same is neither required nor is it a guarantee that something is fair. We're allowed to treat people differently. I think the thing that comes up is the distinction has to be one that is relevant to the way that we're treating them, right? I actually don't remember where I heard this precise definition of fairness. I think it's a common one, but it is treating people equally unless there is a relevant distinction, right? So for example, someone being in pain is a relevant distinction when we consider giving them pain medication, but someone being cute is not a relevant distinction when we're giving pain medication out, right? Giving someone having size 10 shoes is not is a relevant distinction when we're giving people shoes, right? So there are certain reasons that we actually are allowed to treat people different, and in fact, we may have to treat them different in order to actually have this ideal of fairness. The other big thing that many of these were thrown in there is that it's possible to do something that is totally irrelevant to fairness and is just dumb, right? Like, for example, we can give everybody pain medication, but it's just kind of a waste of pain medication because not everybody needs it, right? And this, I think I would anchor to, last time we talked about our two big ethical branches of utilitarianism and deontology. And deontology, like fairness, is really rooted in a deontological tradition, right? There are these rules of, hey, you can't treat people differently just to be an ends to a mean, or a means to an end. But it doesn't really comment on, are you allowed to do things that are just kind of dumb? Whereas utilitarianism really says, no, like you should try to do the things that are smart, right? So giving everybody pain medication might not necessarily be unfair, but it wouldn't be socially beneficial, right? Which is that first AI principle that we talked about yesterday. We want to be both socially beneficial and we want to be fair and not reinforce bias. Let's see. Polar Void said DES ... It's a bad word. I don't know what word we're talking about. If I said a word that was offensive to anyone, I apologize. But I think we're done with Kahoot, but thank you for playing. Oh, I guess we should see who actually won, shouldn't we? Oh, deserve. Yes, yeah, deserve is a bad word. I don't like it. Is it fair? Let's see. College Bunker in third place. Dr. Racket in second place. And, drum roll, y'all. Drum roll. Day in first place. All right, round of applause for everybody. And, Fancy and Jalapeno. Also runners up. Well, thank you for playing. Y'all weren't able to hear the audio, right? The audio was just a me thing. My sense is it was just a me thing. Okay, this is interesting. 54. This is overall 54 of answers were answered correct, which is interesting. Have you stopped? It's fine. We can look at the performance together. No questions were too challenging. Okay. Oh, Moonlight needs help. I'm sorry. I shouldn't have shown that. Of course, all of these are judgment questions, and none of them have sort of very strictly correct or incorrect answers. No, I actually had none of them as it depends, which arguably any of those you could say it depends. It depends on X, Y, or Z. If you give someone a size 10 shoe, but they don't have feet, like, okay, sure, it depends. But for all of them, those were the takeaways that I had. So without further ado, let's fire up Colab. We can create a new notebook for today. We're going to mostly be just charging ahead, doing some new things. Oh, Hanla Pano is okay. I totally was just saying jalapeno. Apologies for that. Yeah, no, I forgot about what I said so fast. I'm probably not doing great at my New Year's resolution then. Okay, let's call this. We'll call this Getting Serious. Boom. We'll call this Global Hack Week. Global Hack Week 2022, 23. Part 2, Getting Serious. I can type. It's literally my job. Okay, that's our title. So, what are we going to do? So, okay, first, I guess we can just download our, I'll share this as well. We can download our data set and we can start actually getting serious. Yeah, I think I call a lot of my notebooks Getting Serious, because there always is the day where we get serious because we're playing around and then we pull out our libraries and our big tools. Okay, so we built a very basic machine learning model last time, and there were, of course, many things missing from our analysis, right? I really appreciate that nobody was like, wait, but Will, why aren't you doing X, Y, or Z? Because we have 4 sessions to fill, and we're kind of spacing what we're doing out across them. I think that building your own model is a really, really sort of helpful tool to think about what's going on. But we're really reinventing the wheel here, right? And so what we're going to do is we're going to use this library called SciKit Learn. It is I'm trying to think of a good analogy, but SciKit Learn, I think, is often the library that is like easy to use and usually good enough is like the pitch that I would give for SciKit Learn. You can get serious with, TensorFlow or Keras or PyTorch. But just in a lot of cases, SciKit Learn gives you just a really, really easy way to think about your machine learning problem, and it'll do just fine for a lot of problems you actually want to solve. So we're going to introduce some realism. One big thing we were also missing last time is we tried to optimize for accuracy. And this actually, it covers up some of what a bank would actually care about. So we're going to introduce some realism by really actually putting on our banker hats and being like, hey, we're trying to make money. How would we make money? So let's start with that first AI principle of trying to be socially beneficial, right? Actually, I guess for starters, I'll drop the link and we'll just import our data. TensorFlow that Fancy Appleby did not know was owned by Google or produced by Google. I don't know. Was a Google project. Oh, you could hear the Kahoot music. That's good. It's initializing. Incredible. We can import pandas as PD. Remember, pandas just lets us interact with our data as if it was a spreadsheet. And we can say read CSV. And I think it's in Global Hack Week 2023-02 / what is it called? Loan applications. CSV. And we'll store that in df. And we can do a little df.head just to get a refresher on what our data looks like. So we have race, we have credit score, we have zip code, and we have will someone default, right? Let's see. Okay. So something that I also want to do before we really get into this, because we're putting on our adult pants right now. Something that we did not do last time is we ran our model on all of our data. But something that you want to do when you are really getting serious is you want to have a training set and a test set. And my classic way of describing this is like a teacher that gives you a study guide and they have separately a test they're going to test you on. Because if they just gave you all the questions they have, you could just memorize the answers and it wouldn't actually really be a good test if you learned something. So we're going to use, we can say import, we'll say from sklearn.model selection, import train test split. This is actually, interestingly enough, even when people are using like TensorFlow and a lot of other tools, often they will still use train test split from SciKit Learn because it is simple, it does the job, and there's not really a big need to iterate upon it. Another thing I want to do is last time we swapped the direction. So currently our variable is will they default, but we want to turn a positive into a positive. And so we will, instead of saying will they default, we'll say are they credit worthy? And that's basically the opposite of if they'll default. So we can say df is credit worthy. And we will set this equal to the value of will default if that's equal to false. This is basically saying just flip it around, and if they will default, then they're not credit worthy, and if they won't default, then they are credit worthy. So now we can use train test split, and so we can, I guess first we'll write our actual call, train test split, and we can put in our our input data and our output data. And so remember, our input data is sort of all the information we have to predict from, and our output data will be, are they credit worthy, right? So what we can do is we can say df, in order to select all of the columns, we'll say in another set of square brackets, we can say credit score, which is obviously going to be in our model, and we'll grab all our other input data of race and zip code. We'll look at actually how we could use that a little bit later, but it'll be helpful for us to just start out by grabbing all of it. So now we can say df is credit worthy, and so this is going to be our sort of y value. We can also say test size. Maybe we start out at like 0.2. That should give us a pretty good, actually, let's do 0.3. And then another thing we're going to do, because we're going to run this several times, we're actually going to put in a random state. The classic random state that folks use is 42, because, answer to the meaning of life or whatever. But this means that if we run this function in the future, we should get the same output because we're starting with that same random input. Let's see. What if you set it up to approve any loan to yourself and your friends? I think that would be fair. Yeah, I feel like this is the equivalent of the doctor giving pain medication to people that are acute. If you obfuscate that code enough, anything is possible. So true. Really what we're learning about AI ethics is how to hide your misdeeds, because it's only unethical if you get caught. I think that is philosophically robust. I don't know. Let me know in the comments if that sounds right. Okay, so we can run this. Oh, and so now we get out here is actually 4 different things. We get our training input, our testing input, our training output, and our testing output. So we'll actually grab this in 4 different variables. So we can say, usually what we'll say is we'll say x train, x test, and then y train, y test. But the way that you could say this is, what are the questions for our study guide? What are the answers for our study guide? What are the questions for our test? And what are the answers for our test? So now if we run that again, oh, excuse me. And then something that we can do just to verify this is we can just look at the length of x train, and then we can also look at the length of x test. And we would expect that one of them is about 1/3 of the size of the other, and this actually looks right? The 35,000 is roughly a little bit more than 3 times. Wait, is that true? No, a little less than 3 times, because our test size is 0.3. Not 0.3333 repeating. Wait, that would mean it's a little bit above double. That's what I actually mean. Because 2/3 is 2 times 1/3. Cool. So we have a training set and a testing set, and now we're just going to try to recreate the work that we did yesterday using a library. So we can talk about the actual model a little bit, but there's a thing called logistic regression. So in the broad world of supervised learning that we talked about yesterday, you often will talk about your different models being either classifiers or regressors. And a regressor or a regression model basically outputs some kind of like real number, right? So we a long time ago predicted house prices, and that was a regression model because it gave you a number of how much we think this house is worth, right? In this case, we're doing a classifier because there's not really there's not like a real value number that it's like, well, this is how much we should approve you for. That would be a different model we could write. But right now our model is just, should we approve you or no? It's a yes or no. And so this is a classifier, right? And so usually what you will do for this kind of classification problem is you will generate some number with all of your math, and then you will feed that into what's called the sigmoid function. Not sigmoid, a logistic function, which now I want to see if I can code the logistic function from scratch. I believe the logistic function is, I think it is, let's see. So if we said, or we'll do just like a lambda, we'll say logistic is equal to lambda x. And so I believe it is 1 over 1 minus, it's, we would write it 1 to the power of negative x. Is this correct? As x gets really, really big, e gets really, really small. Yes, I think this is actually correct. But the way we write this in Python would be np exp. So this is just how you raise something to the power of e. We'll have to import numpy, import numpy as np. I guess, okay, I don't actually have to prove this, but now I'm curious if I got it right. Let's just look up. What is the logistic function? Okay, this feels like a more generalized model. You shouldn't you put the import to the top? This is a question we can dive into. Okay, yeah, I'm actually gonna say oh wait, it's 1 plus e to the power of negative x. Okay, I was very, very close. But the point is, you feed your number into this function, and you end up getting some number between 0 and 1. And we think of 1 as being like yes, you get approved, and we think of 0 as you don't get approved. You don't have to think about too much. You don't have to think too much about this, but basically this is a way of turning our little threshold into math that is really easy to optimize. So what we can do is we can delete this, and we can actually say from sklearn linear model, because this is considered a linear model, we can import logistic regression. Isn't that nice? And so now what we can do is we can actually prepare the data that we want to feed to our model. And so we can say, a notion that we'll bring up is this idea of vectorizing something, because all of the data we feed to our model has to be in the form of numbers. And so right now, credit score is already a number, so that's going to be easy. But race and zip code aren't. So if we want to use race and zip code in our model, we'll have to do a little bit of pre-processing to them. Let's see. So Fancy Albu says, shouldn't you put the imports at the top? So this is something that, in terms of like where you put your import statements, I know in a lot of languages there are like pretty strong rules about this. I mean, like if you are writing like a Python file, generally the thought is, yes, like you should just have all of your import statements at the very top, and then you should later like write your code that uses them. And I think that if you are writing like if I was going to check in some code into the Google code base, like absolutely I would do that. I think one of the joys and values of Jupyter Notebooks and of Colab is to not having to think about things until you use them. And so the reason that I actually write my import statements right next to where I use them is because I don't want to have a giant block of imports at the top, and then when we get down to use something, it's like we've forgotten if we used it. Also because sometimes people will take little screenshots of something, and basically you want to make sure that all of the code that's relevant to that, or all of the import statements relevant to that code, are like close to that. So not necessarily a good practice for if you are checking code into a repository, but yeah, that is why I do what I do. Okay, cool. So logistic regression. We want to vectorize our data, meaning that only numbers exist in our data. So we can say xtrain vec for our vector. And the simplest way, if we're just recreating what we did yesterday, we can actually just grab credit score, because credit score is already a number, so we don't have to do any pre-processing on that, right? Then we can do x test vec and do the exact same thing. Also note that we're pulling these in double square brackets. And the reason we're doing this is because we actually, even though we only have one number, we want to think of this number as a two-dimensional array. And doing double brackets sort of does that for us, because pandas will interpret that as, well, it could be any number of columns. And so I will give it to you in 2 dimensions. But if that's not intuitive to you, don't worry about that. Yeah, Adam, I think actually I'm gonna encourage you to, even though I love having you on stream, I'm gonna encourage you to go to bed, my guy. Polar Void says, kind of an aside, but what about the criteria for identifying race? I imagine there may be many changes if people self-identify, and even more if you take into account multiple races. This is a really, really good question. It's not one that I am super prepared to engage with, but I think it is a good one. I know at the very beginning of yesterday, I did mention, hey, we have a very simplified version of race in this data set, and it is largely because that is kind of the data you will likely get if you are doing this kind of work from from census data or stuff like that, because there are lots of forms out there that have simplified versions of these things. And I think this is it's a thing that actually pops up in a lot of different cases, right? So like, I think we talk about this with gender a lot, is, oh, do you say on your form, if you're trying to get people's gender, do you say man, woman, non-binary, other? Do you say, like how many categories you add? Do you just add a text box? I think the answer in a lot of cases is like, you just don't need to ask for people's gender. And I think similarly, I think the same can be said for race. But there are, of course, cases where we care about it because we want to try to ensure that we are not being unfair, right? The only reason we can do this project is because there is race in this data set. And I think that how you generalize this kind of work to when you let people self-identify and you let them, actually express what they understand their racial identity to be, I imagine it gets tricky. And yeah, I think that is. I don't have too much more to say on that. But if anybody has thoughts on, how do you? I mean, obviously there is just the very straightforward kind of dumb answer of, oh yeah, the more categories you have, the less sort of people you're forcing into each category, and therefore like the less you learn about those categories, kind of. which is kind of the underbanked take. But I'll think about this more and maybe talk about it in future days. It will also maybe seem a little bit more relevant as we get into some more of the trying to measure fairness. Okay, so we've just gotten our vectors here. And now we can actually spin up a basic regression model or a basic logistic regression model. So we can say basic model equals logistic regression. And then we can say basic model. So this creates the model, and then dot fit lets us say train this model on some data. And so we'll want to train it on our vectorized training data. And then we can just use our Y train without actually pre-processing at all. And we are then going to score our model on our testing data to see how we did. So we can see basic model. Oh, we have basic model, and we can say score X test vec and Y test. And technically, I believe this gives us the correlation coefficient between our input data, between our predictions and the answers. And when you only have two classes, generally speaking, your coefficient of correlation is it is not logically equivalent to accuracy, but I'm going to kind of pretend like it is for a little bit. Fancy algebra said, is it the less accurate the data, the less possibility people will be recognized? Interesting question. Tell me more, because I'd love to respond to this, but give me more details about this thought. It is responding to the like letting people self-identify versus putting people into relatively prescribed sort of like identity boxes. Okay, cool. So our basic model got again, not exactly, but we'll say 81.5% accuracy. And that is actually, compared to what we were doing yesterday, really, really great. I don't know if anybody remembers, I could pull it up from yesterday, that we had, let's see, I guess, collab not part two, untitled, boom. If we scroll to the bottom here, we should still have our output. Oh, okay. So when we actually beefed up, we did get close to this. So this is actually a nice confirmation that we basically did just as well, just with less work, right? So there we got 8169. Here we get 8158. The other big difference here is actually here we're doing it on data that our model hasn't seen. So if we did actually this exact same thing, it's likely that our old model would have performed a little bit worse. But we're certainly in sort of a comparable space here. We're looking at about 81% accuracy. Cool. And that was not hard. Hopefully nobody's feeling like that was crazy difficult. And so our predictions were like 81% of our predictions were correct, right? It's a little bit more sophisticated, and I think it is a helpful tool to actually see what threshold does this model pick. So the way this model works is a little bit different because it has both a intercept and a coefficient. And so basically the way that this works is it says, so we have our credit score, it multiplies it by some coefficient, and then it subtracts some intercept, and it says, is this greater than 0? And if it's greater than 0, then we give them a loan, and if it's not greater than 0, we don't give them a loan, right? So if it's greater than 0, we give them a yes, and if it's less than 0, we give them a no. And so the way we can actually see what our model is doing under the hood is we can say basic model dot COEF with an underscore. And then we can say intercept basic model dot intercept with an underscore after it. This gives us an intercept of negative 7.87. So the way we could actually try this out is we could say, okay, if we have a credit score of 700, if we multiply that by our coefficient, and then we subtract our intercept here, is this greater than 0? And this is 1.9. So that's like, heck yeah, you can have a loan. Well, what if our credit score is 400? We run this, we do the math, and it's a negative 2.2. That's like, heck no, you can't have a loan, right? So this is the parameters that our model has learned. Hopefully this bridges the gap from what we were thinking about yesterday to today. Oh, congrats on uploading your assignment, Adam. Good night. Okay, Fancy Appleby got back to me. Like, sort of, the more information people give, the more people find out who you are. But the more you obfuscate the information, the less likely people are to be able to find out members of a group. Yeah, so I think that if I'm understanding what you're saying correctly, the more information people give, the more people can find out. Yes. So like obviously the more information, and we're actually talking about this later about when getting more data on people is useful. This actually becomes a very specific thing that can be used to try to improve the fairness of a model. Another thing that I feel like has to be said here is this kind of gets to the thing that we tried to clear out at the very beginning is there is AI ethics where the thing you're trying to do is generically trying to do good. And sometimes your model can sort of not do what you want it to do. And then separately, there are cases where what you're trying to do is bad, and then it kind of doesn't matter. I mean, like, sure, if you have a better model, there you're just like doing more bad, kind of, right? And so, like, certainly, I would say I think there are a lot of applications of machine learning out there where like you get more data on people, and that's bad, right? That doesn't necessarily have to do with the the fact we got more data on them was bad. It's the fact that we're using that data for an end that is bad. Like we threw out those examples of, like for example, I'm very suspicious of using AI to try to profile people based on their descriptions, or like there are these services where you get a DNA sample and it tries to try to tell you what someone looked like so you can go and arrest that person, right? I'm very suspicious of things like that, and that actually has nothing to do with I think they had too much data or not enough data, but just that I think that the ultimate end of that, I think, is problematic, right, for a free society. That is, I think, a separate point. But yeah, here, given that in general, like us wanting to give people loans, in theory, it should be an engagement that is good for them and good for us, right? It should be mutually beneficial. Separately, we can talk about policy and like, the idea of housing as a universal human right and things like that. But sort of in our world here, we're talking about something that we want to offer loans to people who it will be good for them to gain access to financing. That was, I know, a very, very sort of roundabout conversation about what we're doing here. But hopefully that responds to what you were saying. Polar Void said, we've gotten a similar accuracy ourselves too, right? Yes, yeah, this is very similar to, it actually makes me feel really good about the work we did down here. We implemented our own little threshold classifier and it gets pretty good results. I think the beauty part here is that we didn't have to write much code to get this result that is basically as good. So we could look at the coefficient and the intercept, and that's super cool. And hopefully that all makes sense to everyone. Oh, I guess the other thing we can do is we can actually find our threshold by dividing our intercept by our coefficient, right? If you go and do the algebra, you can say, okay, here's our threshold. If we divide it by our coefficient, what number do we get? And this says, okay, your threshold should be 560. I wonder where that compares to where we got down here. And okay, yeah, our last threshold was like 563. So really, really close, the different models of trying to evaluate this. So I think we'd have a lot of confidence in the work we did yesterday. So the thing I want to step back now and do, now that we have sort of an adult model that we just fed our data in and we got some good results, I want to talk about sort of some financial realism, right? So the bank, so our boss gave us this problem, and our boss said, hey, I want you to build this model to help us predict if people will default on their loans and if we should give them loans, right? And one thing your boss knows, and something that you've talked about, is that every time you give a loan to someone that they pay it back, y'all make like, I don't know, 100K on that loan, right? You make some profit. But every time somebody gets a loan and they don't pay it back, you lose way more money than you make from successfully giving someone a loan, right? So there's some factor of giving a loan to someone who's not going to pay it back is like several times worse than just not giving a loan to someone who would pay it back from your perspective, just purely financially as the bank, right? And so there's going to be some kind of comparison here. We can do some sort of like, to motivate this example, we can do some sort of simplified math. So look, we could say the average, here, let's do some text. We could say the economics of being a bank. So let's say the average home loan is 500K for easy math. And let's say that every time someone pays back their loan, so we'll say profit from a loan being paid back. And let's say that you as the bank get to pocket 100K. This is, over the course of 30 years or whatever, but they end up paying 100K in interest. This is not actually like what the math would look like, but it'll make for easy numbers, right? And let's say the loss from a loan being defaulted on. And this, again, just for easy math, let's say this is the full 500K, right? So this means that someone defaulting on their loan is 5 times as bad as us just not giving someone a loan who would pay it back. Does this math make sense? The place we're going to go with this is similar to our example of telling somebody that they have cancer when they don't really have cancer is kind of bad, but telling someone they don't have cancer when they really do have cancer is like really, really bad. And for us as a bank, the giving someone a loan when they're not going to pay it back, that's the thing that's really, really bad for us. This has nothing to do with morality at all. This has nothing to do with ethics. This just has to do with, we're trying to make change happen. We're trying to have a positive impact, but we're also passionate about keeping our job. And if we don't adhere to this math, our boss is going to be very unhappy, right? Polaroid said, could we see how that cutoff would look like by race if we just use it as is? This is a great question, and we will look at this in a second. That is on its way. Daylove says, what courses do you recommend to learn to do all this? Be a little more specific. Is this like on like SciKit Learn, on Python in general? I would say I totally can drop some recs of learning resources, especially at the end if you remind me. Because I know that like many times we will spend the entire session learning machine learning, and in this session we're like spending a lot of time just talking about ethics and ethical ramifications, and not that much time actually learning the machine learning. So happy to drop some other resources. Okay, cool. So conclusion: giving a loan to someone who will default is 10 times worse than not 10 times worse, 5 times worse than not giving a loan to someone who wouldn't default, or who would pay it back, who will pay it back. Okay, I want to let that sink in, but I'm going back and forth on the ordering here, but because Polaroid asked about it, I'm actually going to do this first. I want us to look at how things affect folks by race. Cool. It's fun though. Incredible. So something we can do is we can so we evaluated the accuracy here, right? We said okay, 81%. We could even be a little bit more rigorous about this and actually get our like true accuracy, but the numbers are basically the same. But something else we can do before we dive into the economics of being a bank, something we can do is we can not just look at the accuracy of everyone everywhere, but we can look at the accuracy sort of specifically on how accurate it is on folks of different races, right? So we could say, let's say evaluate by race. And the thing we'll accept in here, so I want this what do I want to do? I want in here, I want us to put our, we'll give our X okay, let's say we'll have our input data, our predictions, and our actuals. Or we'll say correct answers. That's maybe a little more clear. And so what we'll do, actually, let's not have this be a function at the beginning, and then we'll turn it into a function. And so what I want us to do is basically we'll loop through all of the races, and we'll basically see how good were our predictions on all of them. So in order to actually get some predictions, we can say basic model dot predict, and we can give it our let's say our X test vec, right? And this will give us our test predictions. A basic model test predictions. So now what we can do is we can do that loop where we loop through all of the races we have. So we can say for race in sorted df race dot unique. So we're getting all the unique races in our data set. We're sorting them, and then we're just going to loop through them. So if we just print this, we should just print out all of our races in alphabetical order: Asian, Black, Hispanic, White. Cool. Now we'll actually grab, what we'll do is we'll grab the indices of all of the races that we have. So this is the, I don't want to spend too much time talking about like the pandas magic happening here, but if you work with questions on it, I'll certainly field those. So what we can do is we can say X test regular. We can say race equals our current race. And what this is going to do is it's actually going to give us, I mean, I can print it out. It's going to give us a list of trues and falses. It basically just say, this row right here, it is false that it is equal to our current race. And what we can do with this is it basically gives us a list of all the indices at which we have data of a particular race. If this feels complex, don't worry too much about it. But what we can do then is we can then, from our predictions, from our basic model test predictions, we can just grab the predictions that are relevant to the current race we're looking at. So we can say preds by race. We can also do this for, remember, our answers are in Y test, and we can use that same set of indices to grab the same set of rows. And so we'll say this is correct answers by race. And so what we're going to do with preds by race and correct answers by race is we can do the same math where we actually calculate accuracy, right? So we can say the sort of calculation for accuracy is do our predictions equal our correct answers, add up all of the times that that's true, and then divide by our total number of predictions. And this we can print. We can even do a fun little format string. So we can say the accuracy for blank folks, we'll put in a race, is, and then we can put in our accuracy right there. Oh, my emoji thing popped up. Okay, cool. So if this, I do love format strings. If this works as intended, we should see all of our accuracies. Okay, cool. So this is without doing anything, just using credit score as a cutoff. This is our accuracy on different folks. So we have an accuracy of 82% for Asian folks, an accuracy of 80% for Black folks, an accuracy of 77% for Hispanic folks, and an accuracy of 83% for white folks. You could multiply these numbers by 100 to actually get, nice little percentage numbers. I want to dive into what's going on here, but I actually want to do this tomorrow. But you should have a little bit of consternation already that we already kind of see that our model is performing not quite as well on specifically here on Hispanic folks, but it's also performing worse on Black folks, and it's performing the best on white folks, right? And so this means that, this means that literally, like, our model it works worse for people who aren't white, right? It is more likely to misclassify you if you are not white. Which, okay, sure, it's not by a crazy margin, it's by like what, 6%. But if you're in that 6% that is not getting a house because you are not white, like, that really, really sucks. And we think of that, and we think of trying to be socially beneficial. That is like a really, really big harm that we're imposing on people, not because we're trying to be bad, but because our model is bad, right? Our model is actually misclassifying these people. It's not that there are more Black folks that that would default, or more Hispanic folks that would default. That's a separate number that we could also look at. But here, like, the base thing is, even when a particular person is deserving of a loan, I hate that word. Even when a particular person would pay back their loan, we are not giving it to them because our model is performing worse on them. That's a lot to take in, and we will dive more into this. But it was raised by Alvin, so I wanted to dive in. And now we're going to see, we're going to try to improve our overall accuracy, but we will in a bit look at what that does to our sort of accuracy by race. Also, let's actually repackage this into a function so we can reuse it later. So we'll call this evaluate by race. And we will plop this down our input data and input data, and then our predictions and our correct answers. So this should work just the same now. So we can test this out on our X test and basic model test predictions and Y test. If it works, it should give us the same answers. Okay, yeah, so we have the same answers as before, and now we can just easily reuse this. But actually, I'll reformat this a little bit, and we'll just say accuracy, and then up here, we can just print out erase. Actually, we'll put a little tab in here, \T, tab. Now maybe it will look even prettier. Oh no, what am I doing? Oh, printed out in the wrong place. Cool. We have, for all our different racial categories, we have our accuracies printed out. Okay, so we took a brief intermission to think about how our actions affect other people, but now we're going to get back to being a bank. And we have to deal with this economic math of it's 5 times as worse to give a loan to someone who will default than it is to not give a loan to someone who will pay it back. Any questions about that concept? So the question this raises is, how do we make it so our model understands that it is 5 times worse to sort of make a mistake in one way than it is to make a mistake in the other way? And the answer is that the logistic regression classifier actually gives us a really, really easy way to do this with something called class weights. So class weights basically does just what it says. It allows you to weight your classes and say that, well, this kind of outcome is actually way more important than this other kind of outcome. So another way of phrasing this is that we want to classify people who will default more accurately. We care more about getting that right than we do about classifying people who would pay it back right. And so because paying it back and being creditworthy is 1 in our data set, and defaulting or not being creditworthy is 0, we can grab we just copy and paste our original model up here. And we can put in here class weights. And so we just get to say, this is how important these things are. So how important is it to classify the class 1, which is when people do deserve it? We'll give that a 1. And how important is it for us to classify zeros correctly? Or how important is it for us to classify people who will default correctly? And that we'll say is 5. So our model is now saying, ooh, it's 5 times worse when I misclassify someone who defaults. And so I'm going to be really careful about not messing that up. And so what we can call this is no longer a basic model. This is now what's called a max profit model. This model is built to try to maximize our profit by making sure we don't accidentally give loans to a lot of folks that default, right? This is not anything to do with morality. This is just has to do with being a bank and trying to make money. Punisher X says, why no play Hogwarts? And I don't have any response to that. Okay, so we have our max profit model. And now we can train it on our training data. So we can say max profit model. We could say, max profit model dot fit. And we can pass in x train. We'll say x train vec and x test. And then we can say max profit model dot score on our x test vec and our y test. I guess we need y test up here as well, or y train. I'm getting confused. So these are the questions and answers to our study guide, and these are the questions and answers to our test. And so when we score it, oh no, class weights. Was it just supposed to be class weight? I think it's just class weight. Okay, oh, this is great. This is great. So we told our model, hey, I want you to maximize profitability by weighting this one kind of outcome more than this other outcome. And what happened to our accuracy? Well, our accuracy up here was overall, it was like, what, 82%? And now our accuracy has dropped to 69.9%. That is not nice at all. But why did this happen? Well, the thing this reminds me of is, I think it's called, is it called Brown's Law? Brown's Law? No, that's not what it's called. There's a thing that's like, it's better for 10 guilty men to go free, quote. Okay, cool. Blackstone's law, not Brown's law. Blackstone's ratio. It's better that 10 guilty persons escape than one innocent suffer, right? So it's like making this trade-off of let's let a lot of guilty people escape to let one innocent person suffer, or to prevent one innocent person from suffering. So this means you're basically deciding, because these classes aren't weighted the same, that we're actually going to sacrifice accuracy to achieve something else, right? And so here we are sacrificing accuracy in order to get more profit by switching off. We're willing to have 5 people, or like our math says, we're willing to let 5 people who deserve loans not get them in order to prevent one person who won't pay back a loan from getting it, because that is what our financial math tells us to do. And besides just generic realism and the fact it will be important later, I actually really, really find this part of the project important, because we are introducing this idea that accuracy is not like the end all be all, that we are allowed to, and often do, make decisions to trade off one kind of performance metric for another, right? So our boss just told us to trade off a little bit of accuracy for more profit, right? Those are different things that we can choose to optimize for, and we are making a choice to optimize for profit in this scenario at the expense of accuracy. And the reason that I want to be very clear about this is that there are lots of other things that we can choose to trade some accuracy or some profit or some combination of different factors for. And we're going to dive into a little bit more what those things are as we go forward. Bullet Void says, I have a bad feeling about the score by race. Yeah, that's interesting. Before we do that, I actually want to look at something else, which is something called a confusion matrix. So is anybody familiar with a confusion matrix? Let's see if I can pull up a good picture. I don't want to get too complicated here. Okay, sure. This isn't bad. Oh, where'd the table go? Okay, so this table right here is what we call a confusion matrix. It's don't think about it too deeply, but it basically just shows us how many correct predictions we did in different categories. So this is actually the reason that I wanted us to frame our positive in terms of being a positive. So our positive is they get a loan, right? That's our positive. And when we correctly classify our positive, that's what we call a true positive. When we incorrectly classify someone as getting a loan when they shouldn't, that is called a false positive, right? When we correctly classify someone as not getting a loan, that's a true negative. And when we incorrectly classify someone as not getting a loan, that is a false negative. If you have taken a COVID test, you may have this idea of like, yes, it's possible to have false positives and it's possible to have false negatives, right? And this is a fundamental idea for understanding that not all of our errors when we're building a model are equal. So the thing that I want to do now is actually code up the math for calculating our true positives and our true negatives. And I want to see how that changed when we changed our sort of our profit math, right? So how would we calculate our true positives and our true negatives? Well, one way we could go about this is we could say, let's actually get our predictions. So let's say, or actually, let's define this as a function. We'll say get what are we going to call this? Get confusion matrix. We won't have a full confusion matrix, but bear with me. So all we have to accept here are our predictions and our correct answers. And so what we're going to do is we're just going to say what percentage of the true cases did we classify as true. So we'll say of all the times that they should have gotten a loan or they were creditworthy, how many of those did we classify as true? And then we'll divide it by the total number of true cases there were, right? So the first sort of maybe we do this as an example. We can do y test, and if we just count up how many times is this equal to true, and we can just sum it up. Cool. So there are 940 cases where they are creditworthy. This is like the number of trues that there are. Separately, we can say how many times. Let's actually predict based on test fac. We can say dot predict to get predictions. We can say max profit predictions. And so we can actually count how many times max profit predictions equals our actual answers. And there we have 1,056. Okay, yes, yeah, this is true. But then we also want to see how many of these were actually true. And I think actually the way that we want to do this is we actually want to use some set notation. I believe is actually the way this ends up being easy. So we have our two different series here, and we can calculate how often did people. So how often was the prediction correct? But then we can and that with how often the actual answer was say yes. If we sum all this up, we should actually get the number of, so this is the number of people who deserved loans that we classified correctly. And if we just divide this by the total number of people who deserved loans, then we should get what's called our true positive rate. This is to simplify this, I've typed out actually the math here, but to simplify this, what this is saying is what percentage of people that will pay back loans did we offer loans to, right? So this we can copy and actually make our, we'll call this our TPR, or our true positive rate. And instead of, we'll just say predictions, and then y test is correct answers. Does this bit of math here make sense? I know I was a little bit meandering in actually typing that out, but this actually is what a lot of the next 2 days ends up hinging on. So if you want me to like rerun through what does this number mean, or what are we getting, or how are we getting it, don't worry too much about this but we're basically just saying how many times was the prediction correct and the correct answer was true, that we got it right, and getting it right meant giving them a loan. And this is our true positive. You know what? I'll spell it out. True positive rate. Polar Void says it makes sense. But Polar Void is also a nerd, so you know, it's hard to say how indicative that is of the population at large. Okay, cool. So now we want to calculate our false positive rate. How often did we get it right to not give someone a loan? And this is actually going to look pretty similar. In fact, it's going to look identical. All we have to change is, instead of asking when the correct answer was true, we're just asking when was the correct answer false, right? Now we can print out true positive rate and print out our true positive rate. And then we can say true negative rate and print out our true negative. Okay, yeah. Oh, this is important. This is not our false positive rate. This is our true negative rate. How often did we get the negative class correct? True negative rate. Now we can run this both on our max profit predictions. We can get the confusion matrix for our max profit predictions and y-test, but we can also run this for our basic model predictions. And I'm curious I'm curious to compare these. So we could say print basic model, and then we can print our max profit model. And this is great. So our basic model, it most of the time classifies the people who should get loans. It classifies them correctly. And it's still most of the time, but 68% of the time, if you would default, it says, yeah, that person would default. Now, our max profit model, remember, says it's 5 times worse to have a false negative than it is to have a false positive, right? Our max profit model says we're okay if we deny a lot of people, as long as we don't approve anybody who we shouldn't actually approve. And what happens to our true positive rate and our true negative rate? Yeah, Polar Void said it. Ouch. It gets our true positive rate gets really, really bad. I mean, it is almost flipping a coin here, right? We almost get half of the people who should get loans don't get loans anymore. And in fact, and then of course our true negative rate is great, right? We are really, really good at telling people who shouldn't get loans, hey, you shouldn't get a loan. And we're really, really bad at telling people who should get loans, hey, you should get a loan. We have decided to be a lot more stingy, for lack of a better word. How does this feel? Does this feel okay? I mean, like, hopefully it feels bad, right? And I have bad news, is that this thing right here, specifically, this financial math, is actually not something we're going to fix in the course of this live stream. I would say who gets housing and those kinds of things, that's just regular ethics. But what we're here to do is AI ethics, which is a very specific problem. And I don't want to overshadow the fact that people not having access to, say, homeownership, that is actually a serious, real issue that I think folks should spend time thinking about and trying to solve. And actually, specifically in my case, I would say that it's really, really good if we encourage the building of more housing so that more people can have nice houses. Housing in general. But that's a digression. What really is our concern is, given that this bank is going to do this, it's going to do this mathematical thing, is can we make this fair, right? And can we make it socially beneficial? So one thing that we can think about doing is, well, okay, if we're going to have this trade-off of 1 to 5, maybe we can just make it more accurate for everyone, right? Maybe we could just make it a better classifier regardless of, of the trade-off between true positive and true negative rates. And one thing that we often think about doing is, can we throw more data at this problem? And we actually have more data in our data set, right? We're just looking at our max, or we're just looking at credit score here, but we have these other things that we actually already know that they correlate to the outcome that we're interested in, right? We have race, we have zip code, and so maybe we could use race and zip code to actually improve our model so that we get better accuracy for everyone. And so that's what I want. I think that's the last thing I want to do today, is see if we can just introduce these things into our model and see if we can get better accuracy. And I think the way that we're going to go about this is, so we're going to have to turn our categorical data into numerical data, right? We said all of the data we give our model has to be numbers. And so something that we can do is we can use a tool called one-hot encoding. Add some text. We can say, trying to improve our model for everyone by adding more data. Oh, I forget that that Markdown marks things out when you put squiggles around them. Okay, so I'll use a simple example here just so hopefully we can understand the concept. So say I have some data, and we're going to call it, let's say, weather in Seattle. And we have a list of the weather that I've seen in Seattle. And so let's say it's rainy, snowy, rainy, and let's say I get one sunny day in there. So these are all categories, right? We have 3 categories: rainy, snowy, and sunny. And we could create a data frame out of here. So we could say df, or what was it, weather df, PD data frame. This is just kind of creating a spreadsheet-like thing like we had before. And if we look at our weather df, cool. We have these 5 rows, and it says rainy, rainy, snowy, rainy, sunny. Now, if we want to turn these into categorical variables, one-hot encoding says, instead of just having one column that is like the list of all our categories, what if we had a single column for each category? And we'll say it's a 0 if it isn't that category, and we'll say it's a 1 if it is that category. And SciKit Learn gives us some fun tools to make this a little bit easier to orchestrate. So we're going to say from SciKit Learn .compose, import column transformer, and we'll also from sklearn.preprocessing import one-hot encoder. And then we can say our column transformer is equal to column transformer, not improt, import. And we put in a list of basically the things we want to do to transform our columns. So we can say, we can include a tuple in here, and we can say one-hot encoder. Again, don't worry too much about the implementation details here. I just want to show you what this looks like on an example. So we can say one-hot encoder is actually the way we're transforming our data. And then we can say what column do we actually want to transform here. And you can say multiple columns, but we can just say weather in Seattle. But this is the name of the column we want to do this to. And at the very end, we can give an option for what we do with data that isn't actually transformed. So we can say remainder equals, and pass-through is sort of the default of keep all the data there, even if I didn't actually one-hot encode it. And so now that we have this column transformer, which is a little bit of a hassle to write out, I totally understand that, we can say fit transform. And then we can pass in our weather in Seattle data frame. And then we can call this weather one-hot. And if everything went according to plan, we should see 3 columns where each column represents one of our different categories. So if we compare this, we can basically see the first column is it rainy? The The second column is it snowy? And the third column is it sunny? And so this first row, we have a 1 for is it rainy, a 0 for is it snowy, and a 0 for is it sunny. And if we hop down to the very end, we have a 0 for is it rainy, a 0 for is it snowy, and we have a 1 for is it sunny, because this last one is the category is it sunny. How does that feel to everyone? One hot encoding feel good? This is something that if you've come to Global Hack Weeks past, we have certainly talked about one hot encoding. This is just the way that we're going to be able to feed this additional data into our model and hopefully get better accuracy for everyone. Polar Void asked, how much does the 5-to-1 thingy change the accuracy by race? That will be, I think, the last thing that we actually look at. Yeah, I do. That is kind of the place that I want to end on this session after we add some things. Oh yes, yeah. 404 Not Found 19 asked, what am I painting this Global Hack Week? So I have in the past painted my face and my hair and my arm with tattoo ink. But today this week, everybody has submitted prompts for me to feed to ChatGPT, and ChatGPT has given me prompts of answers of silly things to do on stream. So actually, we're far enough in. I will drop the feedback form, and so now we can all vote on which silly things I'll do. In fact, actually, we've learned about one hot encoding. I think it's totally fine to take a short little break now. I've been going at it for a hot minute. So let me grab feedback form number 2. Boom. Let's see, what does feedback form look like? So these are all of the things that that ChatGPT had for me. It's I act out a scene from The Silence of the Lambs. I am the king of the flower kingdom, and I will hear out petitions from my subjects, that are you. I perform a flamingo dance, and I play Merry Little Lamb on the ukulele while standing on one foot and make animal noises for each chord. I chop vegetables using my ice axe, and I play Truth or Dare with ChatGPT. Let's see. So somebody recommended something else that I wanted to add. Oh, thank you. Yeah, I do. I am very proud of the lens that I have on this camera. Teehee. So yeah, if you fill out this form, you can vote on that. I'm trying to think. Somebody recommended something that I actually wanted to add to the list. If you remember, if you recommended something, let me know and I'll add it to the voting. But yeah, you can go and vote up a storm. Good stuff. Okay, so let's add our additional data and see if we can't improve our accuracy. So the thing we're going to want to do is we can even just copy this column transformer little bit here. And now, instead of transforming weather in Seattle, we can transform race and zip code. Because remember, these are categorical pieces of data, and so we can't feed them in directly unless we transform them. And so the thing that we'll transform is, we'll say CT fit transform R X train. And we can call this X train vec full. Why don't we say full? Not fit transform. What did we say? CT fit transform. Oh, I just misspelled transform. Teehee. Yeah, we're just one hot encoding. We're basically using linear regression for all of this. This is much more a session about how we evaluate the fairness of our model and less about how we build, the sort of highest tech model ever. Because the data we have is really pretty simple here. Okay, start training vec full. Let's see. It looks like okay. I'm gonna trust that. Looks fine. It is very, very big. We've got 13 columns, which I think makes sense because we had 8 possible 8 possible zip codes, 4 possible races, and 1 credit score. So is that 13 total things? I think so, yeah. And we want to do the exact same thing for our testing data, but in that case, we can just say dot transform. So we can say x test vec full column transformer just transform. So we fit our transformer on our on our training data, and then we can just use what we learned to transform our test data. And then our x, of course, are already done, and we don't have to mess with them. So now we have this, and we can say, we'll call this next model our full model because we're considering everything. So this is equal to linear. We'll grab the same linear regression bit, and we'll keep our weight classes, right? Because our boss, once they realize that we can maximize for profit, they're like, well, we got to do that, right? We got to maximize for profit. And so we have our full model. We can now train it on our data that now contains all of the data that we have, all that demographic data, and then we can test it on our test data. We'll say y train, and of course y test. Now, I think this is always a fun game to play, is to try to think about, well, what do I expect to happen here? We know that these other categories, this categorical data, did correlate with whether or not folks were going to default, right? We know it contains some information, but we think it contained way less information than their credit score, right? Their credit score is kind of the whole thing. And we were getting like 80, what was it? 80, oh, so we originally were getting 81% accuracy, but under max profit, we're getting 69% accuracy. So do you think it's going to improve? How much do you think it's going to improve? Put a little guess in your brain there, in your little noggin. And okay, we get 72% accuracy. And I think this is one of those times that if you've been in machine learning for a long time, you're like, heck yeah, 2%, 3%. If you haven't been in machine learning, you're like, what? Only 2%? But to think of it this way, we had like 5,000 people in our data set. If we use this on another 5,000 people, what is 2% of 5,000? What 1% would be? What 1% is 50 people. 2% is 100 people. So this improvement represents us actually getting better predictions for 100 people out there, right? And that's real, and that's something that if we could do it, we would want to do it, right? So in terms of that first column of, hey, we want to do the thing that is socially beneficial, making this change and including all this additional data does, we would say, in sort of the broad terms, it gives us better predictions on more people. 404 asked, wait, so what did we change in them? All we changed now was including all our data. Our first model only used credit score, and this model now uses credit score, race, and zip code, right? So we're throwing more of the information we have on applicants at our model. But of course, Polar Void's doing the thing that Polar Void often does, which is like jump ahead to the thing that I have planned out to talk about 30 minutes from now. And sometimes I humor him, and sometimes I'm like, no, we're gonna get to it. And so this is one of those things. Is of course we want to think about how this impacts folks of different from different protected classes, right? We want to have this eye towards fairness. And so I want to revamp. We've written a lot of code to do comparisons of accuracy across races and this getting confusion matrix. And I want to actually merge these into one. So I'm going to grab our true positive and true negative stuff and paste it down here. And then I'm also going to grab our evaluate by race function. And we're going to patch this all together. So what we can say, oh no, yeah, we were just using the weather example just to talk about one hot encoding. If you want, I can drop we originally had, let's see, copy, boom. This was our original exploratory data analysis. And so we looked at how these different things correlated. So for example, credit score and whether or not someone defaults is one thing we looked at. But yeah, take a look. It's interesting data. So now we're going to patch all this together to have one mega sort of evaluate how we did function. And so we want to look at accuracy. but we also want to look at the true positive rate and the true negative rate. And, well, I guess, yeah, we calculated accuracy. And here we can say we have preds by race. So we'll replace our predictions with preds by race. We have correct answer by race. And so we'll replace correct answer in all those places. So we're just splashing the same math in here. And now we can print it out. And I'll shorten it to TPR and TNR. We can put in our true positive rate and our true negative rate. This will sort of be our final analysis of how are we doing on fairness. Hopefully that works. Also, why don't we actually print out accuracy across the entire data set? And maybe we do true positive rate across the entire data set as well. So we can say, so for everybody accuracy, and we can just say predictions and correct answers. And we'll do the same thing. We'll copy our true positive rate. So we want to see just in terms of the entire data set, how are we doing on accuracy and true positives and true negatives? We also want to see sort of based on every one of our protected classes, how are we doing as well? I know this is not the kind of coding I like to do on stream where it's just like, yeah, we're just mashing a bunch of code together. Don't worry too much about hopefully this function is understandable. And if you have questions, please ask them and we can walk through it. But what we're doing here is we're calculating accuracy, our true positive rate and our true negative rate for our entire data set. And then we're looping through every value for race we have and calculating these same numbers to see how accurate are we on Asian folks, how accurate are we on Black folks, how accurate are we on Hispanic folks, et cetera, et cetera. And so now we should be able to evaluate what our model is doing by, we can try plopping in, I guess we have to get predictions. So we can say full model dot predict, and we can plop in our test data and we can get full model predictions. So now we should be able to evaluate, we have our X train or X test is our input data, our predictions are full model predictions, and Y test is our correct answers. And let's see what the damage is. So at the very beginning here, remember our accuracy is 72%. That was an improvement. We felt good about that, right? That makes it more socially beneficial for everyone. But then our TPR and our TNR are 59% and 93% respectively. So I actually want to scroll back up and see earlier, we had 56% and 92% under our max profit model for our true positives and true negatives. So if you deserve a loan, you're 56% likely to get one. And if you don't deserve a loan, you are 92% likely to not get one. And under our full model, we actually most of our improvement is among our true positive rate, right? So most of our improvement is being better at identifying folks that actually should get loans. And so that's actually really great news. So now if we look at our individual categories here, so we are still doing, it looks pretty good on Asian folks, and it actually looks like in terms of overall accuracy, there's not super big drops between accuracy, right? We're 72% accurate for Asian folks, 73% accurate for Black folks, 70% accurate for Hispanic folks, and 71% accurate for white folks. So no super big differences there. But let's look at our true positive rates and true negative rates. And our true positive rate for Asian folks is 71%. Our true positive rate for Black folks is 27%. Our true positive rate for Hispanic folks is 46%. And our true positive rate for white folks is 64%. And so the big thing that jumps out is that our true positive rates for Hispanic folks and Black folks are much, much lower, right? So like the way to sort of, I think it's really powerful to reframe these things in English. Like, okay, what is this cluster of math actually telling us? And this tells us that if you are a Black person who is applying for a loan here, you are, if you will actually pay it back, there's a 27% chance that you will get it. But if you won't pay it back, there is a 99% chance you won't get it. So we are really, really good at not giving loans to Black folks, and we're really, really bad at giving loans to Black folks that would pay them back. And so this obviously is, I mean, this is why we started this whole session with that Kahoot of is it, is it fair? And if there is a meaningful distinction, then generally we say, yes, we're allowed to treat people differently, right? We're allowed to not give loans to people who wouldn't pay them back, and we're allowed to give loans to people who would pay them back. That's a distinction that is okay. But here with this true positive rate, we are only looking at people who would pay them back. And if you are an Asian folk who would pay an Asian person who would pay the loan back, you have a 71% chance of getting it. And if you are a Black person who would pay it back, you have a 27% chance of getting it. And so the thing to understand here is that the relevant difference is not actually that would you pay it back or not. All these people would pay back the loans. The only difference is what is your race. And the way we anchor our definition of fairness is that when it comes to getting a loan, your race is not a relevant distinction, right? This is like saying we only give pain medication to people we think are cute, or this is like saying we only give an A to Alice because her name starts with A, and not an A to Bob because his name doesn't start with A, right? This is not a distinction that we can actually feel like we are being fair if we base our decision based on it. And that is what our data is showing us. So we did a lot of math today, right? This is like, I think the core big idea for us looking at fairness is not just looking at accuracy, but really diving into, well, what kinds of mistakes are we making, and how are we making these mistakes differently for different people from different backgrounds? And that is, I think, like, honestly, this is the big, like, everything else we talk about in this track is really going to be an appendage to this idea. It's really going to be something we build on top of this idea of what kinds of mistakes are we making, and who are we making those mistakes on, and how do those mistakes affect those people. It is something that I was telling somebody that I was doing this AI ethics track, and they're like, "Oh, okay, I imagine that's like going to be one of the easier ones you're going to do." And I was actually like, "No, I don't think it is. I think it's one of the actually more math-heavy kinds of things you can do in machine learning, because you have to hold a lot of these conditional probabilities in your head at once. But I think it's really, really important to think about these things, and so we're going to continue doing so for the next two sessions. So I think I'm going to leave it there. I'll hang out and we can field questions. I know there are a few things that I told folks to say, hey, wait until the end. I will also drop the feedback form again. Let's see. Yes, EDA. We love EDA. I'm going to put that on the stream. That's an important one. Yay, EDA. EDA stands for Exploratory Data Analysis. That is really important, and I think we actually don't do enough of it on Global Hack Week AI, to be fair. Okay, 404 said, isn't the most improvement in TNR? I also realized that TNR also stands for Totally Not Ryan, and that's a very, very important acronym in Global Hack Week canon. So apologies for overwriting. But yeah, so most of our improvement was, if we just look at the top level of like the whole data set, our original true positive rate was 56, and our original true negative rate, I think, was already like 93. It was 92. So it was 56 and 92. So most of our improvement actually was in the true positive rate, and not a lot of our improvement was in the true negative rate. So basically, with that additional information, basically all we did was give more loans to people who did deserve them, right? Who did deserve them. We gave more loans to people who would pay them back. And we actually didn't use much of that data to deny people loans because we were already denying loans to like most of the people, right? But it's a good question. Let's see. Polar Void said, aren't zip code and race also fairly interdependent? 404 said, let me hide the current comment. Said, no, actually won't. Similar races live closer to each other. So this is an interesting question. And I think this is a really important place to not like to just look at the data and try to understand what the data is saying, and to not assume too much, but to try to ground these things in a sense of history and like what we understand about demographics, right? So these, okay, yes, yeah, interdependent, not independent. And so we did our EDA and we looked at, okay, yeah, this is our races by zip code. And there certainly is, it can be tough to know like, oh, exactly how related is these two categorical variables. But we certainly see that there are spikes in each zip code, right? So in 71200, in fact, in both of these first ones, we have sort of high numbers of Asian folks and white folks. In this 71202, we have a decent chunk of Asian folks, and then a lot of white folks. In the second one, really, it's just mostly white folks. And you see that there are these correlations, but this is not always going to be true, right? We know that definitely there are different parts of, both different countries, but also different parts of like say the U.S., but also different parts of the same city that will have varying degrees of homogeneity, right? There are certainly neighborhoods in a lot of cities that are predominantly like a lot of cities will have what are they called? I think they're called enclaves. Like groups where you have a lot of folks from similar racial backgrounds. And then you also have plenty of places that are really, really integrated. And so that's the thing that it's important to do this EDA first, because we couldn't just assume that without actually looking at the data. Can I get this data on Kaggle? Like if this is real data, I'd like to see how it was collected, because the data does tell a very sad story if based on real data. Yeah, so I'm going to explain where this data came from on day 4. We'll look at it then. Yeah. The thing I will say now is these are not actually the these zip codes are not actually the real zip codes, if that makes sense. Daylove says, can you share some resources? Yeah, are you the person that asked on like learning about data manipulation? Model training and data manipulation aspect of this. Yeah, absolutely. So one thing I would say is one very convenient resource is all of the other streams this week. Certainly a lot of them deal with that. Kaggle is actually one that I will second. Kaggle is a great resource for finding data sets and for don't look at that URL, and for learning about things, right? You can go to data. There are tons of data sets. The competitions are super useful as well. I would say that broadly, this is really, really useful for if you have done a little bit of machine learning and you're looking to sort of build your tool belt. If you're really starting at the ground level, this might be a little bit much. I also actually would recommend, I know it's kind of shameless self-promo, but most of the past streams that I have done, which I think you can actually still find on MLH's YouTube, they should be archived, I think are fairly good resources. The learn section, yeah, I actually did, as I was getting this, I did, okay, this is kind of embarrassing. You'll see I'm 65% of the way through the intro to AI ethics. Obviously this is, actually, if you want to know where a lot of the basis of this session came up from, oh yeah, the secret one that I took away that I made an oopsie in. But there are two big resources that I depended on a lot for coming up with this, which this is a little bit, you asked more on the non-AI ethics side of machine learning. But yeah, Intro to Machine Learning, Intro to Python here are actually really, really great. So would totally recommend those. If you're just learning for basic Python skills, I think their Python thing is fine. I actually would recommend Codecademy. Has a really, is it free Codecademy? Codecademy. Yeah. I personally really like Codecademy, and you can do basically all you want to do for free. Actually, I should drop that link. Which, I mean, there are tons of resources. These are just some of the ones that I have found useful. Academy, Kaggle. And then, because we were just talking about it, two of the big things that I used for this course. One is called the ethical algorithm. Oh, and is there a PDF? Perhaps. But it's certainly a book. And you know, I would say, hey, support the authors. It is certainly an interesting read. It talks through a bunch of different branches of sort of what does it mean to have decisions made by algorithms, and to try to have those systems be ethical. And then the other one, actually, I'm going to share this. There's an academic paper that a lot of this is based on, that you could find if you just Google around for it. But I'll send it out maybe on Friday. So there's an academic paper that I really like here. Okay, cool. We don't talk about Bruno. No. So true, King. All right, I think we're going to leave it there, unless anybody has any other questions. Oh, Polar Void said, do you buy or make your flower crowns? I will confess, totally purchased. Like $8, I would totally recommend it, 100%. Yeah, I have the backup flower crown in case I lose the first one. Boom. Oh, yes, Fancy Appleby, thank you for reminding me. I will play you out on Kalimba. Alrighty. All right, friends. Happy hacking. I will see y'all tomorrow. Take care.